We are living in the golden age of
I
surveillance.
would just recommend using a normal shielded Zcash wallet on your phone.
Okay.
How are you, man?
I'm doing good, thank you. How are you?
Doing good, yeah. Busy days,
Good.
but we're doing good.
So just to give some introduction, you're Milian, is that how it's pronounced?
Yeah, that's perfect.
And you're working on Arcium.
Correct.
And so could you give us maybe a brief explanation of maybe vague details around your role or some information about Arcium itself?
Yeah. So I work at Arcium. I started here only 7 months ago. I'm one of the fresher ones, but been working here. Arcium, we're building what we like to call an encrypted supercomputer. What that means is that we can do any computation, any arbitrary computation, and do it in an encrypted way. So this is pretty different from what, for example, Zcash enables. It's a different target, a different market, right? So it's more targeted towards public blockchains and giving them private functionality. So it extends public blockchains functionality, and it can also be used independently of blockchains. So it can also be used by other enterprises or organizations that have no business in working with blockchain. Since it's not a blockchain network, it's a non-blockchain network, purely computational encrypted network. That's a simple explanation of what Arcium is.
Awesome. Yeah, this is fairly new. I read your post on privacy 1.0, privacy 2.0. You had another post on MPC, and I think, correct me if I'm wrong, this idea of like providing infrastructure outside of like I should say agnostic of particular blockchains allows for like intents. Is that correct?
Intense. Yeah, sure. I mean, what this means, yeah, our network is chain agnostic. I also like to call it like enterprise agnostic. We only use the blockchain for incentivization of honest nodes and slashing of dishonest nodes.
Mm.
So it's only mostly for the implementation mechanism and creating this game theoretic scenario where honest nodes get rewarded and dishonest nodes get slashed, staked, kicked out, and then the computation can move forward with honest nodes. I can go more into detail on the specifics there.
Right.
Um,
I
yeah.
think perhaps let's start like right at the beginning. So privacy 1.0, where we have like application specific um, platforms like Zcash, where its only capability is to sort of send funds privately, and that's it. Um, yeah, like what else can we say about privacy 1.0? Like I feel as though um, like the label 1.0 seems like it's an old version, and we could upgrade it to something like different. I think maybe it's just a difference. Like privacy 1.0, you have these like purpose built applications which allow for to do one thing very well. Privacy 2.0 things like Arcium and Anoma and like near intents or something, uh, they just allow for a different kind of capability. Um,
Yeah,
because
I can go in that. So yeah, I would like to call privacy 1.0, yeah, as you say, application or specific privacy. So for example, in the case of Zcash, this is a very specific area where or thing that works very good and this is nothing that Privacy 2.0 will replace. So yeah, it's more about Privacy 1.0 being specific and Privacy 2.0 being more general purpose. And the thing, yeah, I also like to say we have these applications on public blockchains that give privacy to users. This is what Privacy 2.0 could replace. Something like Zcash is very, very hard to replace, but something like Railgun or Tornado Cash, that is very simple to replace with Privacy
Yeah.
2.0. Um,
Right, because there is also the consideration of whether you want your privacy on like an L1 or an L2, and kind of how that changes the maybe not the trust assumptions, but perhaps the censorship resistance, where if you're doing it on an L2, you could get the block validators on the L1 censoring transactions or censoring, um,
yeah,
transactions from a specific application, and kind of how if you are like staking a whole bunch of ETH or whatever, you're probably going to follow guidance. I'm saying this, but um, the only example we have is Tornado Cash, I think, and the validators. I've forgotten the website, but there was a way to check which validators were censoring transactions, and
yeah,
it turned out that ETH was pretty censorship resistant,
yeah, yeah,
surprisingly.
yeah, yeah, for sure. So yeah, I think all of them got censored or was not able to do any interactions with the Tornado Cash smart contracts because they were sanctioned essentially,
Yeah,
which shows that these RPC nodes are essentially very centralized, and only a few could do these types of transactions. So that kind of show how censored RPCs is on Ethereum in general, and
yeah,
but it also showed which ones that are decentralized and cannot really be shut down by a sanction like that.
yeah. It's pretty cool. So I think an important thing to cover is exactly how these privacy 2.0 um, like infrastructure projects, how they work. Um, so we could cover MPC. What is multi-party computation?
Yeah. Multi-party computation is essentially what it says. It's multiple parties that do computation together. And how it works, let's say you want to use a multi-party computation protocol. So essentially you would encrypt your you would encrypt what you want to compute before you send it into the server, and this data gets split into shards or specific parts of data that is scrambled, um, and with this scrambled data, multiple parties compute on them collaboratively to create an output. I mean, there's two different forms of MPC. In general, there's multi-party computation. This could also be done in an unencrypted form. But there's also secure multi-party computation, which is where we get this secret sharing, where we get this scrambling effect or encrypted shards. Where yeah,
I see.
so yeah,
So is this like the magic of FHE, fully, uh, is it homomorphic
yeah,
encryption?
fully homomorphic encryption (FHE). Yeah, yeah. We can go into that. So essentially, they work or they produce the same results, right? But there's some underlying differences. So FHE is very straightforward. It's only you send in the encrypted data, and a node runs computations on this encrypted data directly. So there's not multiple nodes collaboratively working together. There's just one node that works on completely encrypted data. And this is
Cool.
really, really cool. And it's also powered by cryptography. MPC and FHE are like the cryptography ways of doing privacy 2.0. And but the thing with it is that it's very computationally intensive. It's very computationally expensive. So an operation with FHE can take a long time, a very, very long time. And there's still a lot of improvements to do to improve that.
Right. Um, yeah, I was taking a look at the Arcium. Uh, is it like a topology architecture diagram?
Yeah.
And yeah, we have like a cluster of nodes which you call MXE. So do those nodes perform FHE computations, or are they kind of like TEEs where uh, data is encrypted on them?
Yeah. So we essentially use different privacy enhancing technologies in our stack. So we mainly use MPC, secure multi-party computation. That's like our core protocol. But in this protocol, we also have somewhat homomorphic encryption, which we do for additions for some faster operations. This is like a milder form of fully homomorphic encryption. And we also integrate, or you have the option to integrate TEs as well to strengthen the MPC protocol if that's needed. But we have two different MPC protocols. One is super secure. I can go into detail on what that means later. And one which is super fast, which was an MPC protocol we acquired from a Web2 company called Infer.
Cool.
Yeah,
Yeah. So
so
does the user get to choose? Like, do they get to define how their data moves across the network, and which parties can decrypt their data? And
yeah, so it's very customizable. These MXCs, you can choose how many nodes want to perform a computation. You can choose if you want added TEs for extreme security. You can also choose which specific nodes you want to use. So we will have like this reputation based system. So honest nodes with concurrent uptime will get a better rating than dishonest nodes with little uptime or similar.
nice.
So it's very customizable in that way. You can choose if you want to use our super secure way of doing it, where you essentially don't have to run any nodes yourself, or you can choose the faster version, which is mainly optimized for AI use cases. In these use cases, it would make more sense to run your own nodes.
Yeah.
Uh,
So I
yeah,
was reading about the AI. So I mean, we've been talking about the technology, but we haven't been talking about really the applications. What are people going to be using Arcium for, and these new types of Privacy 2.0 networks?
yeah, yeah.
Um, yes, secure AI, private AI. Can you kind of explain? Because there is, I think it's called Venice AI, which is
Mm.
it keeps your data private, but I think you're talking about something different.
Yeah, I don't know if Venice really is that private, as
Oh,
they say, to be honest. Based on what I have read and heard from multiple others that are experienced in this, is that Venice AI, they don't log anything, but they let users do. Um, I mean, they have integrated several decentralized networks. So they've integrated, I think, Hyperbolic, which is a GPU network, decentralized GPU network, and one other, I think, Akash. So essentially, what you do is you say, write a prompt, and instead of them, Venice AI doing the computations as a centralized company, they let a decentralized network of different users and different nodes do the computations.
mm,
So the nodes doing these computations can essentially see what is going on in the computation. Venice AI
right.
doesn't, but the people running these nodes can if they want, and they can also log this. So I wouldn't really call it private. But what we are doing is we're allowing private AI training and private AI inferencing. So when you send a prompt to, for example, ChatGPT, the prompt you send in is processed in plain text, and it's also logged, so people can, or administrators of ChatGPT, and also event hackers, if they get in, can see what types of prompts you sent in. With our stack, you would essentially be able to do inferencing in an encrypted way. So
Cool.
there'll be no way for any administrators of a platform or any hackers, malicious users to find out what these kinds of prompts were.
And the
So
same, yeah, this same network that can be used for AI, training AI models, you could also apply to things like data analytics. I think on one blog post there was DNA analysis, like genealogy type analysis,
yeah,
could be done over a privacy compatible network like Arcium.
yeah, for sure.
Yeah,
A lot of different ways. Any type of research, any type of AI, whether it's training or inferencing, all of this could be done on our network. So you could generate very interesting results while keeping data encrypted and truly everything in a trustless way, which
perfect.
is cool. Yeah.
Yeah. I mean, like, just to go on a bit of a side note, a few of my family members did the 23andMe, and I think
Mhm.
that company announced that it was bankrupt, and no one knew where the data was going. And like with AI, you can also like with DNA, you can, so it can be pretty bad. Um,
Yeah.
but
Yeah.
yeah, I mean, this comes to the purpose of why privacy is important. Like why are all of these applications? Why should we be interested in them? Why should we be using them? Um, and there was something Chris Goes, the co-founder of Namada, mentioned at the recent Zcash conference, that really we've become accustomed to poorly designed systems. Like with Web 2, we kind of have this expectation that our data is private. Like most people don't fully understand where it's going,
For
and
sure.
there exist like incentives for the companies to kind of extract more data than they really need and to sell it to the highest bidder.
Yeah.
Um, so it's things like this, Privacy 2.0, where it's kind of fixing the core problem.
Yeah. Fixing the core problem in many things. So essentially, you could also do 23andMe in a privacy preserving way. I think their database got leaked as well and sold on the dark web. And
Uh-oh.
then they got bankrupt. And then they could sell all their data as well to the highest bidder. That was a big catastrophe, but yeah, essentially a lot of the applications people use on a daily basis, many of those could have this privacy preserving way of doing things. For sure, 23andMe or ChatGPT, all of these types of applications could be replaced with a truly encrypted alternative.
Right. And so yeah, which is why I think having like a very specific payments system, like a Zcash wallet or a Penumbra wallet, or just anything that's private that is very good at making payments, let's say, could easily replace Venmo or Cash App. We're
Yeah,
still like very early
yeah.
towards kind of reaching that stage of market adoption. Um, could we talk about composability? I don't fully understand what that means.
Yeah. I mean, we can talk about how Arcium integrates into other networks and enterprises.
Yeah,
Um, so it is a non-blockchain network. It's a purely computational stateless network. So any type of computation you can do on it, but Arcium is essentially optimized for Solana first. So our network is not tied to Solana. We only use Solana mainly as the incentivization layer, but over time, our network will be integrated into other networks. So, for example, Ethereum or Mega ETH or Monad or yeah, whatever will be integrated into these types of different blockchains. And also, so users shouldn't really have to worry about the fact that this is decentralized. That there's a lot of complicated navigation and stuff. Will just be this interface. You connect to it. You can pay with USDC. You can also probably pay with fiat if people want that. So to reduce those barriers, or Zcash for that matter. Uh, and this will, yeah. But
So this is kind of the concept of a shared private state where the
oh yeah,
where the computation is taking place is actually off chain, um, and this state can be shared privately with across different chains, right?
yeah, yeah. So computations happen off chain, and the computation can be verified on chain. That's essentially what it is.
Cool. Yeah. So if we're talking about like crypto usage of Arcium, I've read something about dark pools, and I've seen this mentioned. This term dark pools mentioned in with other projects. Do you could you explain kind of what that is?
Yeah. So in traditional finance, there's this concept of dark pools. They have a very blatant flaw, but essentially what they are not your normal exchanges. So you send money into this dark pool, and in this dark pool, you can do any trade confidentially. So it's not revealed immediately when you place an order or place a bid. This is hidden from other users. So there's no like front running. No high frequency traders can take advantage of a big position that they see in the order book. So the order book or this participant's orders are essentially hidden from the broader market. Uh, so this is in traditional finance. There's no encryption involved. It's like, just trust me, bro. Promise, right? But what we are building is encrypted dark pools or encrypted order books. So in some way, this has already existed before. With Railgun, for example, where you can do a trade, you can do it privately, and people can't really see it in order book. But there's been no order books. I mean, with Railgun, you have to download an application, all of that. There's been no encrypted order books on the usual applications people use and on the web. There is one called Arbitrum, no, Renegade, which is the first dark pool in that way, which is an Arbitrum. But yeah, we're building the stack to make dark pools very easy to use and build on any type of application. So anyone can integrate our stack, write normal Rust code, which people usually do on Solana anyways, or in other programs, and they just mark a few functions as confidential. And then you can
Interesting.
essentially have a dark pool on chain instead of having to write all of this cryptography yourself. You can just write normal Rust code. So we abstract away all of the complexity with cryptography with our stack and our programming framework. So we're making encrypted applications very easy to build, and this includes trustless dark pools.
Very cool. Although, I must say, like, as someone who's coming from the dark ages of like UTXO chains, um, the notion of having like fully private applications and things like dark pools, you kind of wonder if, like, let's say it's some sort of DEX, how do we really know that the funds deposited on into this contract are really there, and not being extracted? Like, there needs to be some kind of verifiability, um, or transparency, uh,
Yeah.
when we're dealing with exchanges.
Yeah. I mean, this would be apparent and verifiable in some way. I'm not exactly sure. I'm not the CEO or CTO, so not exactly sure how that will be implemented. But it has to be implemented in a verifiable way to make users aware that they're actually using an encrypted order book or a proper dark pool,
Yeah.
for sure.
There's um, a chain called Penumbra, and I think their approach is to allow users to be anonymous. It's they use Zcash sapling, and they've just basically added. Uh, they're on IBC as well, but they've added like a DEX to it, so the liquidity positions are all public or transparent, and the actual users just remain private. The accounts, I suppose.
Yeah, yeah, that's cool. That's cool. Yeah, Penumbra's doing great work. Uh, they're on IBC, right? On
Yeah,
Cosmos.
yeah, yeah, yeah.
Yeah, yeah. I've never actually used it since I don't use IBC much, but they're doing great work in the privacy field for sure.
And so, like, I guess this nicely leads on to like potential upgrade paths for Zcash, and what you reckon is the best way that we can move forward. So there is one upgrade planned, NU7, and it's going to introduce something called Zcash shielded assets, or ZSA protocol, and that's essentially like user defined assets. So you could be an issuer of USDC or of any random token, ETH or Solana or whatever, um, and they would live privately on the Zcash L1. So this doesn't include any kind of smart contract capability or anything like IBC. But do you think that Zcash should pursue a path of like programmability, maybe on using something like Arcium, um, and like having this? I'm not going to say layer two, but like computation layer, and having like wallets which have accounts. Um, how do you?
Yeah,
What are your thoughts?
I think there is some synergies here, especially for on ramping to Zcash, maybe. So, but you said that eventually with this upgrade, you would be able to hold assets on Zcash, for example, Solana. You said that?
Yeah,
Yeah, that's cool. That's cool.
it just
Yeah,
it needs an issuer though. It couldn't be like a bridge. Well, I mean, there is a bridge to Avalanche which is being developed, but it couldn't be a uh, like a smart. I don't know how to say it. There needs to be an issuer on the Zcash L1 chain
yeah,
holding. Yeah,
yeah. Makes sense. Yeah, I think that would be cool. There's definitely some synergies with encrypted computation and Zcash. I mean, you're doing encrypted computation in one way, um, but yeah, I'm wondering how this will work in the future. Well, I think our CEO is planning something there, maybe.
yeah,
But I think this would likely be in the bridging way in the first. I think that's what we thought of first. For example, Zcash, for making onboarding to Zcash easy and private, obviously. So
indeed.
essentially, yeah. So essentially, with Archim, it could create private bridges easily by having a mixer in between the mixer and or from the user sends to a mixer, and then get bridged, and then to Zcash, for example. And they don't really have to have an anonymity pool for this, since it's all encrypted on chain. But yeah, in a very different way with MPC.
Yeah.
Yeah, Ari Hunt, our engineer, could probably talk better on this than me. But yeah,
Yeah, I'm not really a developer or an engineer myself. I just like to think
yeah.
about the possibilities. But yeah, I guess we kind of covered everything that we were kind of speaking about before. Thanks for coming on.
Hey, thanks for having me. Nice to meet you,
Awesome.
Squirrel.
Nice to meet you, Milian. Take care.
Take care, man.
Bye.
Bye.